Hey everybody, welcome to Math with Ace. Doing some statistics. We're going to focus on Venn diagrams and tree diagrams these next few videos. The first one, we have a tree diagram. We are dealing with an urn that has 11 balls. 3 are red and 8 are blue. We are using 2 draws with replacement, meaning I draw a ball, see the color, put it back in, and draw another one and see the color again. In the diagram, I am using frequencies, not probabilities, not relative frequencies, just how many options there are. I need to list the 24 outcomes. There are only 3 red balls, but there are 8 blue. And so the first blue ball is listed with all of the red combinations. So I need to do that for blue 2 through blue 8. Blue 2, red 1, blue 2, red 2, blue 2, red 3. On to blue 3. Blue 3, red 1, blue 3, red 2, blue 3, red 3, blue 4. Blue 4, red 1, blue 4, red 2, blue 4, red 3, blue 5. Blue 5, red 1, blue 5, red 2, blue 5, red 3, blue 6. Blue 6, red 1, blue 6, red 2, blue 6, red 3, 7. Blue 7, red 1, blue 7, red 2, blue 7, red 3, and then 8. Blue 8, red 1, blue 8, red 2, blue 8, red 3. Okay. Now, I'm not talking about how many ways this could happen. I'm just talking about the outcomes that are possible. So I could draw blue 2 first or second. I could draw, so there's multiple ways that things like this can happen. Using the tree diagram, calculate the probability of being red and red. These frequencies here add up to 11. This adds up to 11, and this adds up to 11. Down here, I have 64 because there's 8 blue options. I've listed all of the blue-red outcomes. Now, these blue-red outcomes could occur first or second. I could draw blue 1 first or red 1 first. So these are all things that could happen forward and back. So there's actually 48 of these outcomes, 24 blue-red, 24 red-blue. But then we also have blue-blue outcomes. There are 64 blue-blue. Blue 1 with blue 2, blue 1 with blue 3, blue 1 with blue 4, and so on all the way through. So there are 64 out of how many total? Well, how many options are there? There's 64 plus 24 blue-red plus 24 red-blue plus 9 red-red. That's 121, which is 11 times 11. So there's 64 out of 121, 24 out of 121, and 24 out of 121, and 9 out of 121 to turn those into relative frequencies. Using the tree diagram, I want to calculate the probability of being red, red. So what I'm going to do is I'm going to go to the red and red area and record that probability, which is 9 out of that 121. Now I'm asked to calculate the probability of red, blue, or blue-red. Well, here is my red blues. Here are my blue reds, and they are mutually exclusive. You cannot be both blue red and red blue, so I can just add the 2 of them. That means I can take 24 out of 121 plus 24 out of 121 to get 48 out of 121. Okay. Now I want to calculate the probability of red on the first draw and blue on the second draw. So on the first draw, red is here, and then blue is here. That means I have 24 out of 121. And that's an and. So this is red and blue. Now, using the tree diagram, I want to calculate red on the second draw, given that I was blue on the first draw. So this is a conditional probability. Blue on the first draw. There are 8 ways that that could happen. Okay, does that help us at all? Let's see. Blue on the first draw. And then I'm looking at here, how many do I have total? Of those total, I have 11. Okay, so there's 11 total. And I'm looking at red on the second draw. How many of those were red? 3. So this simplifies to 3/11. You could calculate the probability of being red on the second and given blue on the first, or red on the second and blue on the first, and then divide that by the probability of blue on the first, which would simplify down to 3/11. So if we did the probability of red 2 and blue 1, and then divided by the probability of blue 1, red 2 and blue 1, let's go back to my chart and erase some of these. Red 2, blue 1, there's 24 out of 121 there. And then I divided that by all of the blue on the first draw. Yeah, just make sure I'm getting this right. So blue on the first draw was all of these. Okay, so 64 plus 24 out of 121. So I have 24 out of 121 times 121 over 88. These simplify, and I have 24 over 88. I'm doing some fraction math over here. Divide this by 8, and I get 3/11. It's the same probability. I didn't like that. That was way more complex, right? Rather than just going to the branch that I was focusing on and how many on that branch. Okay. Using the tree diagram, calculate the probability of being blue and blue. Blue and blue is here. There was 68 out of 121. I'm sorry, 64 out of 121. Okay. Lastly, using the tree diagram, calculate the probability of blue on the second draw, given that it was red on the first draw. Okay, so let's go to our red on the first draw and how many of those are blue. Red on the first draw is here. So on the second draw, we had 11. How many of those are blue? 8. We already know what happened the first time with your red. Out of those that we still had 11 left, 8 were blue. All right, let's do another problem. An urn has 3 red marbles and 8 blue marbles. Draw 2 marbles, this time without replacement. Okay, without replacement. That makes a difference because what's happening is I'm changing how many balls are in the urn after I draw the first one. So I'm not putting it back. And what color I get makes a difference. So on the first draw, I had 3 red and I had 8 blue. There's 11 total. On the blue branch, that meant I got a blue. So I don't have 8 anymore, I have 7. But I still have all my red. On the red branch, that means I got a red. So I now have 2, but I still have all my blue. But because I took 1 out, I don't have 11 anymore, I have 10. And 10 times 11 is 110. Okay? So remember, these are our intersection probabilities down here. So this is the probability of red and red, the probability of red and blue, the probability of blue and red, and the probability of blue and blue. Okay, calculate the following probabilities using a tree diagram. The probability of red and red is here, which is 6 out of 110. Now they're asking us to fill in the blanks. The probability of red-blue or blue-red. So red-blue or blue-red. Red-blue is here. And they have 3/11 times 8/10. So 3/11 comes from here. The 8/10 comes from here. Now I need to do the same thing for blue-red. So those two fractions are 8/11 and 3/10. Now, what is the probability that we got red on the second given blue on the first? Well, let's look at that branch and focus. Red on the second given blue on the first. That's what I'm focusing on. Okay. Red on the second, blue on the first. So I'm only caring about this group here to the left. And here is our probabilities. What is the probability of getting red? 3 out of 10. Fill in the blanks. Red 1 and blue 2. Okay. So red 1, blue 2. Where is that track? Red 1, blue 2. That's 3/11 times 8/10. 3 times 8 is 24. 11 times 10 is 110. That works out. What is the probability of blue and blue? Same idea. Let's go up to our chart. Blue and blue. Blue track, blue track. That gives me 56 out of 110. 8/11 times 7/10 is 56 out of 110. And then lastly, we want the probability of blue 2 given that we have red first. So let's go to the red side and look at that second draw and see how many blues there are. Focusing on the red side, on the second draw, how many of those were blue? 8 out of 10. Okay, so there's a given conditional probability before you do the intersection on each of these. All right. Head on over to our next video as we focus on more probabilities with tree diagrams.